of time today, so let's quickly get started on drawing a triangle in DirectX 11. D3D11 triangle. Stream info updated successfully. Alright. Let's see. How far can we get? D3D11. That one. That's what we want. And so when we create the context somewhere in here. So what are we doing here? Swap chain, right? This is the swap chain. Create swap chain. Yeah. Swap chain. Okay, so after the swap chain, I'm gonna go in and, well, first let's look at the reference. What is this? What is this? Can we close that? Yeah. Yeah. Okay. So the reference tells us that we're gonna need a buffer. Yeah, we're certainly gonna need a buffer. And that's on the device. Okay. We have a device here. Device LPV table create buffer. Device. We need the description, we need the data that goes into it, and then the return value. Description, data, and v buffer. Let's just call it that. Yeah. Alright, so that we actually have to store this here. ID3D11 buffer, v buffer. Pretty sure that's in, yeah, that's where it's supposed to be. Okay, create buffer, what does that return? Let's find out. H result, yeah, that makes sense. Yeah, let's just assert H result. Assert that this is you. Yeah. So that's the buffer creation. Vertex buffer. But we need a description. Mutable. Okay, so D3D11 buffer desk. And what to byte with? Well, I mean, we could just look up what it has. Yeah, byte width, which is the size of the whole thing. Yeah, it's the size of the whole thing. Which we don't have that yet, but we will. So byte width usage. Immutable. Yeah. Default. A resource that requires read and write access by the GPU. A resource that can only be read by the GPU, it cannot be written by the GPU, and cannot be accessed by the CPU. Yeah, well, that is what we want. Usage is D3D11 usage immutable. D3D11 usage. And do we need anything else? Bind flags. Yeah, well, no bind flags. It is a vertex buffer, but we also have all these things. Vertex index constant shader stream render depth. Annotated access decoder video encoder. Interesting. Okay, so we don't have a okay. Vertex buffer. Bind flags. So D3D11 bind, D3D11 bind vertex buffer. Okay, apparently we don't need anything else. CPU access, MISC flags, and structure byte stride. The size of each element in the buffer structure when the buffer represents a structured buffer. Structured buffer, what even is that? Okay, well we don't need either of these, so we just leave that zeroed. MISC flags, texture cube, okay, well yeah, well we don't need any of these. New resource type, structured buffer. It contains elements of equal sizes. These resources require a resource variable to access memory through indexing. Structured buffer. Atomic functions. And in addition to indexing, structured buffer supports accessing a single member like this, MySB27 color. Okay, well, I don't think we'll be using that just yet. Okay, bind flags. So that's the description. Does that compile? It does, except these need to be colons. Yeah, so data size of, I think that's how it's gonna work. We don't have data. Usage, bind flags, byte width. I see, so that we just supply the size, so we don't say anything about what's in the data. We just tell it how big it is. Yeah, D3D11 buffer disk. Okay, so the data is just the vertices, which all we're gonna have is the positions. We're not gonna have anything else. No colors, no UVs. It's just gonna be a float 2. So float 2. We're gonna have 3 of those. Data is -1, -1. It's not that many. So it's -1, -1, then it's 0, 1, and then it's 1, -1. Okay, something like this. Except that all of these need to be that. Yeah. And all of these need to be that. Cannot pass arguments to parameter. Yes. Yes. Yeah, because that's not data, that's actually sub-resource data. It's like data sub-resource. Yeah. Because we also need a sub-resource, D3D11 sub-resource data. 3D11 sub-resource data. Sub-resource data. Data sub-resource. Hello, chatter. How are you doing? Pieces, mem. Yeah, point. What's this structure even? Pitch and slice pitch. Okay, well, it's not a texture. And it doesn't have depth. So what we need is this pieces, mem. Data sub resource spaces mem is data. I mean, I guess it's the address of, right? It's data 0, 0. It's the very first element. Yeah. Yeah, that works. Okay, well, let's see. Install. Okay. Data. Locals. A lot of locals, huh? Well, it displays correctly at least, that's something. Data, description, sub-resource, create buffer result. Okay, apparently we've created the buffer successfully. We have to destroy it as well. Yeah, vbuffer LPV table release. Okay, that's the buffer. Okay, what's next? Okay, we have the buffer. It only has positions, nothing else. Now it's the shaders. Yeah. Okay, so apparently we can use the compiler from the command line. fxc, yes, fxc, oh boy. Yeah, that's a copyright 2013. Shader compiler 10.1. I see. Print this message, options files, target profile. What? Okay, so it's like target vs whatever. Entry point name, that's E. Yeah, that makes sense. 03, whatever, that's just optimization. Disable pre-shaders, disable optimizations. Warning, validation, debugging. ZPC. Back matrices and column major. Oh. Oh. Okay. Force partial precision, avoid flow control, enable strict mode. We'll also have JAS, enable strict mode. We have FH, output header file containing object code. Yeah, that's actually not a bad idea. If we can just have a header file, because we can use those pretty much as is. Well, almost. Output warnings, output assembly code. Assembly code. Output library, output object file. That what you link with. You can also use fo shader.bin to save compiled shader as a binary and provide binary data to create shader. So you can also use fo whatever shader. Fo output object file. So it's not really an object file, it's like a binary that you pass to create shader. Like down here. We have compile. Okay, so compile. So when you call compile, it essentially returns this blob thing. And then you pass the blob thing to the create shader function. I see. So we could output a binary, we could also output a header file, which would then have to turn into some kind of binary anyway. I see. Q strip reflect, what does that mean? Strip reflection data. Q strip debug information, strip private data. That's it. I mean, we can also do other things like root signature, compress, decompress, sh template, merge UAVs, match UAVs, enable unbound descriptor tables, all resource bound, set private, get private, define macro, no logo, profile. So it has profiles, okay. And we're looking for some kind of VS 5 point. Yeah, okay. Alright, well, we're gonna have to write a shader first. Yeah, well, alright. Shader. Alright, what do we need in here? Input. Well, really what we need is VS, right? VS input, VS input. VS input, VS input. Input. So that. So it takes some, produce some output. And then, I mean, all we really have to do is none of that, really. No color, yeah, we don't really need, yeah, we don't have colors. We just return the input. Yes, input. So what do we call it? Just out. Output, position, Right, it's the pixel shader just has position. Yeah. Input position. Return output. Struct PS input float to position. Am I forgetting something? No. And struct VS input is gonna be this. No. VS input, so that. Unexpected token struct. Is there semicolons and yeah. Yeah, that's all we really need. Now we also have this pixel shader which returns a color. Float for PS. Yeah. Any special decorations required here, by the way? No. On the VS input we do need a special decoration. It's just position. And on the PS input we also have a special decoration which is SV position. Yeah, okay. And then the pixel shader itself needs to have a special decoration which is SV target. And it takes a PS input. Oh. Yeah. And it just returns well, we don't really even need any input. But yeah, we don't really even need input, come to think of it. Because we're gonna return the same color anyway. Color is 0.5 and 0.25, something like that. I think it's RGBA. Return color. Oh, we'll find out. And the vertex shade doesn't really have to do anything, really. And we do void. It just doesn't do anything. It has an input and then it doesn't do anything with the input. Yeah. Yeah, but it will though, right? It will. So we might as well keep the might as well keep it. Except this is SV position. Okay, PS input has a decoration, VS input has a decoration, pixel shader itself has a decoration. Okay, so this is our shaders. Let's see what exactly happens when we try to compile that. fxc. Okay, so what are the main sort of commands we need to run? No logo. Well, actually, we can just put that into build.bat. fxc, no logo. Target. VS50. E. Entry point. E is VS. Optimizations, yeah, let's actually disable those. OD ZI. Debug name with source information. Debug name with only binary information. Pack matrices. Well, I'm not using matrices. Jess. Output. Okay. Well, we don't need output. Yeah. So we don't need that ZPC thing. Or WX. I mean WX. I mean sure. FH. Okay, so this is the header file. FH test shader.h. Let's just call it that. FH. I mean it's V shader, right? Specifically. VN. What's that? Use name as a variable name in header file. Oh. Yeah. Yeah, VN is gonna be V shader. Q strip, yeah, we're not stripping anything. And then we just pass it source shader HLSL. Compilation failed. Not all elements were written. Okay. Yeah, PS input. Syntax error input. Not all elements were written. Output signature parameter. Line 9 actually. Output signature parameter 1 based entry 0 type must be float 32 and mask must be XYZW. Oh, this thing needs to be a float 4. Is what it's saying. It's just I don't care. Just fill it with zeros. Oh man, that compilation header save succeeded. Yeah. Oh my god. Oh boy. Fuck. Okay. Okay, well it's 2000 lines. It's really not saving space. Like it's not even trying. Like look at all the double spaces. Like yeah. Why did it align these things? Like what is it expecting me to read this? It's like yeah, thanks for aligning it and inserting all those spaces in here. Really good use of text bytes. Well, whatever. It does work. It does work, but we're gonna have to somehow include that binary. And it's you. Did it have to use this byte macro? Like, did it really? Like this V shader. Like, did it have to use this macro from Windows.h? Oh, it's got some information though. that's something. Refactoring allowed, skip output SIV, dectal temps, initial variable locations. Okay. Approximately 4 instruction slots used, okay. Well, it's got some interesting information in here. So that's something. Okay, so it can output a header file, although we probably want a binary instead. We want a binary, and we want to convert that binary into something we can just include. But we already kind of have that. So maybe it's not really worth it. You can just do this. And then we can just include that. Except that, well, let's try it. I guess source. Let's put it in source. vshader.c. And well, really what it is not even that. It's like, it's per entry point, right? So entry point is vs, and we want this to be like shader vs, something like that. Yeah, that's just the binary representation of it. Oh my god, oh god, no, don't format it. Don't format it. No symbols. And this we can include, kind of, directly. Well, kind of directly. As like import shader vs. Well, yeah, we can. I think we can just do that. What is that? What is that output? Excuse me. And recognize C initial. Yeah, because of byte. Unidentified identity. Yeah, undefined identifier right here. I think we can just define it pretty easily though. EMD help preprocessor dash b equals dash d byte equals char. Oh, yeah, but I can't do that because yeah, I can't do that globally because I'm including Windows.h. Although, I mean, I kind of can. Well, not really. Okay, you know what? Let's just this vshader, right? Shader vs. Let's just change this to char kind of manually, right? Let's comment this out just for now. And if only it didn't use a custom macro, this compiler, and I just used char or something, like, oh man, this is so good. Would have been so good. But that's not what we got out of Microsoft. So what this means is that if we were to do it on the command line, we would have to kind of Yeah, we'd have to do some work to make it work. Which, I mean, I get... How is byte defined? Unsigned char. It's actually a type def. Yeah, it's not defined, it's type def. I mean, I guess we can make it work if we just... So if we comment this out, this will not work. Because it will have been replaced with byte again. But like, what's the... I mean, we could do this, right? So P equals D byte equals... Well, I mean, byte equals char, right? But then, like in here, we can go in and do undef byte. Like, does that work? Yes. I define byte to get shader binaries to work. Yeah. So that'll be just a perpetual problem. I mean, this isn't so bad. It requires very little from us. And then we can just use this, right? I mean, the only problem is that every shader would be like this. Like, you would have the name appear here, you would also have it appear here. And like for every shader that'd be different. I mean, we're not gonna have that many shaders in this project, so I guess that's not a problem. And even if we did have many shaders, well, it's not that hard to synchronize these things, probably. Well, how many shaders are you gonna have, really? And possibly many. Hundreds. Well, yeah, with hundreds of shaders, this model would be a little rough. So I guess you would just put that into a program. And that program can then just write these imports as well. We're not going to be doing that here, though. File with import C. Okay. Yeah, of course. Now we just have this global variable hanging out called shader underscore VS. So we're just not allowed to have that. And what is it, like well, it's a byte array temp is shader underscore. Is that has no value, excuse me? I mean, I'm pretty sure it has a value. It's a char array. Module shader vs has no value. Well, it is a module, true, but there's also a variable inside of it. Is it like that? Ah, it is like that. Oh man. Yeah, I mean that's not great, right? That's not great. Let's call it like global or something. Global shader. Global compiled shader. Let's give the long name. And then the shader HLSL file name is shader.hlsl and the entry point is vs. So that. So that. I'm gonna call it const. Yeah. Unresolved external symbol. Because we actually need this file here, source. Oh man, shader vs. Yeah, we actually need this in here as well. Okay, that's like, let's just see how many places shader appears in. 1, 2, 3, 4. And this specifically appears twice. Well, I mean this, it's not so bad right now. To do shaders. And this just kind of tells me how I'm planning to do that. Yeah. Okay. There's the V buffer. Well, this is all new. Okay, well, this one we're actually not gonna be committing. Git ignore shader vs.c. This one we will commit. And that's just to get it to work. Alright. Start on triangle. Okay, so actually let's make sure we don't get any weird errors. that's fine. Yeah, it seems to be working fine. Alright, that's all I have time for today, so see you later.